In this example, we're asked to work out the gradient of the joining line of the 2 points -2 and 7 and 4 and 5. So first we can plot these 2 points and draw a line connecting the 2 points as shown here. And for us to find the gradient, we can use this equation, which is m equal y2 minus y1 over x2 minus x1. So in this scenario, for -2 and 7, they represent our x1 and y1, and for the second point, which is 4 and 5, they represent our x2 and y2. So in this scenario, we'd have m being 5, take away 7, over, and we have 4, take away -2. So in this scenario, we would have 5 take away 7, so that would give us -2. And we have 4 minus -2, so that would be +2, so that will give us 6. So in this scenario, our gradient will be -1/3. And this will be our answer. In this example, the joining line, the line joining the 2 points 2 and -5, and the second point 4 and 8 has a gradient of -1. So for us, we are asked to work out the value of a. So first we will write the equation of to find the gradient, which is m equal y2 minus y1 over x2 minus x1. So we know we have 2 and -5, so they represent x1, y1, and we have 4 and 8, so they represent x2 and y2. So, and we know the gradient is -1, so we have write -1 equal y2 is 8, and then we have -5 over x2 minus x1, so that would be 4 take away 2, so that will give us -1 equal a plus 5 over 2. Then we will have in this scenario cross multiply, so that will give us a plus 5 equal -2. So that will give us a being, 5 will be moved to the other side, so that will give us a being -7, and this will be our answer. In this example, we are asked to find out the gradient for the lines joining the pair of points shown. So first, we will start with the first pair. So in this scenario, we have we look at 8. So we have 4 and 2 and 6 and 3. So we have the gradient in this scenario will be. So we know for the first point will be 4 and 2, and we have 6 and 3. So that's x1, x2, y1, y2. So in this scenario, m will equal 3 take away 2 over 6 take away 4. So in this scenario, we would have a half as our answer for part A. Now for part B, we will have a similar scenario. So we will have the first point being -1 and 3, so that's x1, y1, and we also have 5 and 4, so that's x2, y2. So the gradient in this scenario will be 4 take away 3 over 5 take away -1. So that will give us in this scenario 4 take away 3, that will be 1, and over 6, and this will be our answer. In this example, we're looking at the points of -1 and 3, and the second point is first point will be -4 and and 5, and the second point is 1 and 2. So we have x1, x2, y1, y2. So m will be equal to y1 take away y2, which is 5, over in the scenario 1 minus 4. So in this scenario, we would have minus 3 divided by 5, and this will be our answer. In this example, we're asked to find the gradients of the lines joining these two pairs of points. So we have 2 and minus 3, and we have 6 and 5. So we'll start with 2 and minus 3, and we have 6 and 5. So in this scenario, we have x1, x2, y1, y2. So the gradient will be 5 take away 2 over 5 take away minus 3 in this scenario over 6 take away 2. So in this example, it would give us 8 over 4, which will give us 2 as our answer. For part B, we have minus 3 and 4, we have 7 and minus 6. So we have x1, x2, y1, y2. So the gradient will be y squared minus 1, or y2 take away y1 over x2 take away x1. So that will give us, in this scenario, minus 6 minus 4 over 7 take away minus 3. So in this scenario, we would have minus 10 over 10, and our answer will be minus 1. For part C, we have the points of minus 12 and 3, and also minus 2 and 8. So we have x1, x2, y1, y2. Gradient will be y2 minus y1 over x2 minus x1. So that will give us 8 take away minus 12 over x2 is minus 2 take away 3. So in this scenario, we would have 8 and 3 take away 3, 8 take away 3, and we have minus 2 take away minus 12. So in this scenario, we would have 5 in the numerator, and we have minus 2 and plus 12, so that would give us 10. So in this scenario, we would have half as our answer. In this example, we need to work out the gradients of the lines joining these pairs of points. So first, we'll look at point G. So we have the 2 points minus 2 and minus 4, and we have 10 and 2. So we find the x1, this minus 2 represents x1, minus 4 represents y1, 10 represents x2, and 2 represents y2. So the equation of the gradient will be m equals y2 minus y1 over x2 minus x1. So in this scenario, we will have y2 being 2, take away minus 4, and in the denominator we would have 10 take away minus 2. So in this scenario, we would have 2 minus 4, that would give us 6 in the numerator, and the denominator would have 10 plus 2, and that would give us 12. So in this scenario, 6 over 12, that would give us a half, and this will be our answer for the gradient. In this example, we're looking at H. So we have the 2 points half and 2, which represents x1, y1. The second point, which is 3 quarters, which represents x2, and 4 will be y2. So the gradient will be y2 minus y1 over x2 minus x1. So in this scenario, we would have 4 take away 2 over 3 quarters take away half. So in this scenario, we would have, to simplify this expression, we'd have 2 over a quarter, and that would give us 8 as the answer for the gradient. Now we look at part I. So we have the 2 points, quarter and a half in terms of the x1, y1, and the second point will be half and 2/3, which will be x2, y2. So the equation of the gradient will be m equal y2 minus y1 over x2 minus x1. So in this scenario, we would have 2/3 take away a half over a half take away a quarter. So in this scenario, we'll try to simplify these two, so it will give us a 1/6 in the numerator over a quarter over in the denominator. So in this scenario, we would have a 4 over 6, which will give us 2 over 3 as the answer for this for the gradient for this 2 points. In this example, we asked to find the gradient of the lines joining these pairs of points. So we start with the first point with the first pair of points, which is minus 2.4 and 9.6, which represents x1, y1, and the second point 0 and 0, which represents x2 and y2. Now we use the equation of the gradient, which is y2 take away y1 over x2 take away x1. So that will give us 0 take away 9.6 over 0 take away minus 2.4. So that will give us minus 9.6 in the numerator, and the denominator will be 2.4. So that will give us minus 4 as our answer for the gradient. In this example, we are looking at the 2 points of 1.3 and minus 2.2, represents x1, y1, and the second point, which is 8.8 and minus 4.7, which represents x2, y2. So the gradient will be minus, so it will be y2 take away y1 over x2 take away x1. In this scenario, we have m equal minus 4.7 take away, and between brackets, minus 2.2 over 8.8 take away 1.3. So in this scenario, we can simplify the numerator and the denominator, so that would give us minus 2.5 in the numerator and 7 divided by 7.5 the denominator, so that will give us minus 1/3 as the answer for this these pair of points. In this example, we're looking at the 2 points of 0 and 5a, which represents x1, y1, and also we have the second point, which is 10a and 0, which represents x2, y2. So the gradient will be y2 take away y1 over x2 minus x1. So in this scenario, we would have for y2 would have 0 minus 5a over 10a take away 0. So in this scenario, we would have minus 5a over 10a. So the answer will be minus, so the a's will disappear in this scenario. So we would have minus 5 over 10, and that will be equivalent to minus a half for this pair of points.